Okay, what we're going to do today is we're going to look at how to do some static calculations in Excel. So in particular, we're going to look at resolving angular forces and resolving distributed forces. Okay, so for the first thing, we're going to look at we're going to be looking at resolving the angular forces. If I have an angle here that is adjacent to a horizontal surface, I'm going to consider that a horizontal angle. And let's say that we're going to just put in a sample angle up here of 30 degrees. Okay, so what I need to do is I need to figure out how I'm going to resolve that to do this calculation. Now, if we take a look at this, when we resolve the horizontal angle with the horizontal surface, that is going to be the adjacent over the hypotenuse. So that means that I'm going to use the cosine. Now, when I do that, whenever I do any type of calculations in Excel, I'm always going to type the equal sign first. Okay, then I would type in cos, and I would basically put a parenthesis. That way, any calculations that I do are inside the parentheses. I'll click on my cell here to signify the angle, close it, and then hit enter. But when you look at this looks kind of funny. It doesn't really look right. And that is, hopefully you see that it's kind of looks a little funny. It should be a familiar number, not like 0.866 or 0.5. The reason why this looks funny is because Excel's default angle measurement is in radians. So what we need to do, anything that we type in degrees, we're going to have to convert that to radians first before we do the calculation. So I'm going to have to go back and I'm going to have to delete this. Now what I'm going to have to do here first is go ahead and type in equals radians and select the cell that has the angle in it. That'll convert that to radians. Then I can go back if I wanted to. Actually, you have to go back and type in cos and put that whole thing in parentheses. And then we get the answer that we're looking for. Okay, so remember, the key thing that we need to note is that the default angle measurement for angles in Excel is radians. So anytime we type in an angle in degrees, we're going to have to convert that first and then do the trigonometric calculation afterwards. That's why it's on the inside of the parentheses. Okay. Now for the other angle, the GY is opposite. So I can go ahead and type in equals. I can go ahead and type in radians and select the angle. And then I'm going to have to go and outside of the radians, go ahead and type in sine and add my parentheses, and there I have my measurements. Now this is basically saying that 0.866 times G is going to give me the value that I need. 0.5 times G is going to give me the value that I need. So let's say that I also want to go ahead and supply a value for G. So instead of having the symbol G here, I can delete that and I can go ahead and type in a value, any value. So let's go ahead and just use the value 10 as a test. And I'm going to move this picture over. That way it makes a little bit more sense. Okay. Now, rather than typing in an again here, what I can do is I can make those cells equivalent. That way, if I change it in this area, it'll automatically change here. So I'll delete the G. I'll say equals, and I'll click on that cell and it'll copy the value. That way, if I ever decide to change this to 20, it automatically updates here. So what I need to do below here to get the true value for GX is I'm basically going to multiply those two cells together. So I'm going to go equals, click on this, multiply the value, and then I can do the same thing down here when I'm multiplying those values together. And there we go. Okay. That way, if I want to change the angle to 60 degrees, it automatically updates. And if I want to change it back to 10, it also automatically updates. Okay. Vertical angles can be set up the same way. We can go ahead and just type in any angle that we want. And again, instead of using the the values there with all the different angles of the sides, we're going to use the trig functions here. So I'm going to go equals. This time I know right away if I'm looking at fx, that is opposite of the vertical angle, so that's going to be sine. But I have to convert my angle to radians first. So then I'm going to go ahead and type in the radians. I've got to close this to close that operation. And I'm going to use the second parentheses to close the overall operation. And there we go. Okay. With this, again, I'll do that again one more time. For the Fy, that is adjacent to the angle. So Fy, it's adjacent. I'm going to use cosine. I got to convert my angle measurement to radians, select my angle measurement, close that operation, and then close the second operation. And there we go. And again, what I can do here is I'm going to move my picture over to the side, and I'm going to go ahead and type in a value here. We'll use 7 in this case. And we can make it equivalent here. That way we don't have to type it in twice. And then we'll do our calculations. Equals the trig function times the value equals the trig function times the value. And that gives us exactly what we need. Okay, that way if I change my angles 45, it'll automatically update everything. And you can see that that spreadsheet works very nicely. Now for the rectangular distribution, and we'll look at the triangular distribution as well, you'll see that I got a value f. Okay, that's going to be my red line here, and it looks like I'm using the variable r here, so I'm going to update that. Okay, my value f, and these are the values, this is going to be where you're going to actually put in your values. So we'll leave this blank for right now, and we'll fill in our values later. Magnitude for the uniformly distributed load, if you remember, it's basically the area of that rectangle. So I'm basically going to take these two numbers and multiply them together. So I'll say equals the force that's here times the length of the beam, and there we go. And it's 0 right now because we don't have anything in here. And then we also need to figure out the location of that. It's going to be half of the length of L. So we'll do equals, we'll click on L, and we'll divide that by 2. Okay? And now we can go ahead and simply type in our numbers that we want. Let's say that we have a force value of 20 and a length of 15. And it goes ahead and calculates those values for us. We can go ahead and do the same thing here for our triangular distribution. Now, we're going to go ahead and use the location. We have to describe where it's being located from. So I'm going to go ahead and add this description from larger side. Okay, you can also designate it from the smaller side if you want, but we're going to go ahead and just use the larger side. Okay, for magnitude, it's going to be the area of that triangle. So I'm going to have to type equals. I'm going to type these two numbers multiplied together, but I need to divide them by 2. So I'm going to add some parentheses here just to be on the safe side. Okay, divide that by 2. Now again, these are zeros right now because there are no values in those cells. Now the location, if you take a look at it, from the larger side, it's going to be L over 3. So I'm going to type in equals, click on the cell, divide by 3, and there we go. That way, if we put in our numbers, we can actually see how nicely it's going to turn out. So I'm going to type in just a 100, and I'm going to type in a 3, and we'll see that that comes out very nicely.